Now, suppose you have a huge table containing client data and you want information about a client whose first name is, let's say, Alex. Now, when you will execute the query, your DBMS will go through each entry sequentially and check for a client named Alex. Now, this would be fine if you have like 1,000 users. But if your company is huge and if it has millions of users, then this is going to be really slow. So we need to do something about it. What if we sort the table by first name? Searching for a first name in a sorted table would happen a lot faster because DBMS can use binary search on first name to reach the record a lot faster. So what we can do is we can create a replica of the existing table and then sort that replica by the first name. But now what if you want information about a client whose last name is Smith? Now because the table is not sorted by the last name, the DBMS would have to go through the database sequentially to find the user. Again, to optimize it, we can create a separate table replica which will be sorted by the last name. But if we keep creating replicas of existing database, we will be wasting a lot of storage. So instead of replicating the entire table, what we can do is we can create a smaller table which will contain just 2 columns. The first column will store the first name and the second column will store the pointers to the original table. So each row in the small table will contain a first name and a pointer to the first name's record in the original table. Well, it doesn't actually point to a record directly, it actually points to a block, which is a collection of records. But let's keep things simple for now. So this smaller table is what we call an index. And by the way, this index will be sorted by the first name. So when you will query the database, let's say you want the information about a user whose first name is Alex. The DBMS will first check if there is an index created on first name. If it is, it will perform binary search on that index, and once it finds the record with the first name Alex, it will use the pointer provided in the record to directly reach the record in the original table. Okay? And similarly, we can create an index for other columns as well. Okay? Now, this is just a basic overview of indexing. In reality, indexing is a vast topic and can be very complicated. Indexes are meant to speed up the performance of a database, but if not done properly, this can even harm your database performance. For example, for all the right operations on a table, you would also need to update the index or indexes related to that table. And so your write operations will be slower. And if you're performing write operations more frequently than read operations, your database's overall performance will suffer.